Hello friends, welcome to our channel Exploring Things Around and our course Learn C Programming A to Z. Today we'll learn about functions in C. So before we start, if you have not yet subscribed to our channel, please click on the subscribe button. Today we'll learn about functions in C and its usage. We'll also learn how we can declare and define a function and how we can pass values between different functions. We'll also learn about the scope of the variables used in the functions. We'll create few demo programs to elaborate more on these topics. So far we have learned about different type of instructions available in C. We have learned about sequential statements. We have learned about decision control statement. We have learned about loops also in the C. So today we are gonna learn about the functions. This is a very important concept in C, so put extra attention to understand it better. So as we learned earlier, C follows top-down approach. So any given bigger problem is tried to divide it into small modules, and we try to build different functions to handle each of these activities or each of these modules. So to learn functions, we need to know few important points about these. So we need to understand few important words related to these, like actual argument, formal arguments, what is function declaration and what is its prototype, how we define functions, what all are the return types. All those things we need to learn. So what I'll do, I'll directly get into dev C++ and I'll create a demo program and I'll walk you through that so that you understand it clearly. I'll create a new program. So let's say it's function demo. I'll keep explaining along the way. Hash include studio dot h void main. So first thing, so far we know every C program must have main function, that is your entry point. So even main is also a function, and today we are gonna learn about user defined functions, or the functions which we can create by our own. So any function, any program will have at least one main functions, and other functions whichever we create, that needs to be invoked from the main functions. Other functions should not be invoking main function. Main function will invoke other functions. So let's print here something. Printf you are in main function. Let's say line 1. So this is your main functions. Now let's assume we have created a function, say function 1. So let's say we have created a function 1, and this will perform some activity. So for now we are keeping ourselves restricted to just printing activity. So we are gonna print here you are in function 1. Let's say here also you are in function 1 and line 1, and again let's say you are in function 1 and line 2. Let's keep new line character as well. So I'll show you what all are the important words to remember related to functions. So just let's go along the program. So here you see we created a function name function 1, and inside that we are just printing two lines, line 1 and line 2. Okay, so this in actual scenario this function can be created to print some alert or warning kind of thing on the screen to user. So for example, in your main function you are doing some validation, some specific activity, and if that condition or the validation fails, you want to print something to user. So that printing active for that printing activity, you might be willing to create a new function. There you will not do anything, you will just print the alerts or warnings to the user. So as I said, in C you can divide different tasks into smaller tasks, and you can create one separate functions for these. So in here also, printing alert or warning, for that purpose also you can create a different function. To perform the validation, for that also you can create a different functions. So it's better to have multiple functions, nothing wrong in that. And having a different functions for a specific requirement, for a specific purpose, it's always better to have a functions for that. It avoids repeating that code in your program again and again. Suppose if you need to perform same validation 4 times at different places, you'll have to write that code 4 times if you are not using functions. But if you have put everything, all of those codes inside the functions, you can simply define that function at one place, and in rest of the places, wherever you need, be it 4 times or 10 times, you don't have to write the whole code again. You just simply need to call that functions, right? So that's how function help us. Also, not only that part, in case in future if you need to or modify that action, if you need to include extra validation, for example, or if you need to perform extra activity, if you are not using function, you have to include this change in all the places wherever that activity is done. But if you are using functions, you can modify it just in the function, you can modify it only in one place. Rest of the places it will automatically refer, wherever it is being called, it will automatically reflect. So these are few highlights of functions, uh, advantage of using functions. So let's see here. So here function one is the name of function. One thing you see, since this function is not returning any value, this is not returning any value, so we can say here void in starting. Okay, so here we'll say void function, and since this, and we can call this function from function one. Okay, so let's call it from here. So this is how we call, we just need to give the function name, and if we are passing any value, if that function takes any value, those also we need to map in the argument. So we'll learn about that. So far we are starting from the simple function, and we'll try to extend that to um, with higher complexity, with more complexity. So for now we are assuming this function does not take any input and it does not return anything, it simply prints something on the screen. Okay, so here we can call the function, and let's print again here and say you are on the line number 3. One thing, so before we use this function in main, so as we know, main C program will follow uh, sequential structure. It will go line by line. So once it comes to function 1, it will not understand what is this function 1, and it will throw an error. So let's try and compile it. Okay, so if you see here, you get an warning conflicting type of function 1. Previous implicit was here. It doesn't understand basically what is this. So for that we need to declare this function before call. So on top of void main, you can define the prototype of the function, or you can declare that function. So to declare the function, three things are required. Okay, one is return type. So first you need to tell the return type of the function, then you to tell the function name, and inside the bracket, if that takes any parameter as input, if that takes any argument. So these three are required to define the prototype of the function. Since here it is not taking any input as parameter, so we can leave that blank. And return type, since it is not returning any value, so we can use void keyword. So this is your function prototyping or function declaration. So this is your function declaration, and on the below where we have performed the activity of that function, this whole section is called your function definition, because here we define what that function will do. So main will be your entry point, and from main you can call any function. So here main is your calling function and function 1 will be your called function. Okay, so two more concepts. One is calling function, okay, and another is called function. So here function 1 is your called function and main is your calling function. So let's compile it now. Okay, you see no error because we have followed the structure. We have defined the function, we have declared the function before using it, and later we have defined it. So if you don't want to just declare the function, you can put the whole definition also on the top. That is also another way of declaring and defining your function at one go. So you could have done everything here, and in that case you would not have needed this line. Okay, so these are two approach. So let's remove this code for now. Okay, uh, and now let's run it. So you will see how the control moves from one function to another function. So it will start from main. First it should print you are in main function line 1. You see control came here, it went to next line. Next line is calling your function 1. So control goes to your function 1. It will print you are in function 1 line 1, you are in function 1 line 2. And once the execution of function 1 is completed, it goes back to next line in the main function, which is your printing of the line 3. So control goes back to there and it prints that thing. So you see here you are in main function line 3. So this is how control moves between the functions. So for there is one keyword also, return keyword. So if you use this function, this will return the control immediately back to the calling function. So return keyword you will be using the called function, and whenever that keyword will get encountered, control will go back to the calling function immediately. So in this case, if we use return keyword here, your you are in line 1, you are in function 1 line 2 printing activity, this statement will get skipped. So let's see also. I'll compile it. You see no error, and now let's run it. So if you see here you are in main function line 1. From function 1 it printed only you are in line 1, you are in function 1 line 1. After that, since it encountered return keyword, so it skipped printing of you are in function 1 line 2 and it went control went back to the calling function. Okay, so this is how control moves between different functions. So for example, suppose if you have more function in your programs, so ideally there is no limitation to how many function you can use, how many function you can define in your program. So for now, let's create one more function. Say it your function 2, okay, and let's remove this return keyword from here for now. And in function 2, you will say you are in function 2 and just line 1. So this function 2 now it can be called from main function also, it can be called from the function 1 also. So as we said, right, we follow top down approach in C. Any bigger problem we try to divide that in smaller problem. So even the below functions also can again be divided into more small functions, and those can be referenced in these functions. So for example here function 1 can refer to function 2. So if you call function 2 from here, okay, so what all we need to declare this function also before using it. So let's declare that on top. So now what will happen after printing you are in function 1 line 1, control will move to function 2, and once it has performed all the activity defined in function 2, then the control will move back to calling function, and in this case your calling function is function 1. Okay, so let's compile it. You see no error. Let's run it. So just remember this thing. Two things are important here, calling and called function. So once called function's activity is performed, control will go back to the calling function. Not every time it will go back to main function. So here if your function 2 is called from the function 1, so control will go back to function 1 once execution of function 2 is completed. So you see here main function, then function 1, line 1, and after that it went to function 2 line 1, and from there control return to function 1 back, not to main function. Okay, and from there again it went to main function. So this is how control moves between function. Control moves in case of different multiple function. This is how control travel among these functions. So every time from main function, execution will start from main function. That is one thing to know. Okay, so let me show you that now in our presentation. So this is how the process flow will work. Execution will start from the main function, and wherever it encounters a call to different function, control will go back to that function. Now it will perform all the activities given in that function, and once that is done, or if it encounters return keyword as I showed you in the demo, right? Else if encounters return keyword, then also control will go back to calling function just after the function call statement. So here it will come back to statement 5. If it is having multiple functions, so here also control will go back to the calling function. So like for example from function 1 you are calling function 2. So once execution of function 2 is completed, control will go back to the function 1. And once function 1 is completed, control will go back to the function main function. Okay, so that is one thing. So now let's see few more important points in functions. So far we didn't pass any value, right? We are using blank return type also, nothing in return, and we are not passing any parameter to the function. So now let's see how we can pass a parameter to the function. So let's assume this function 1 here we are gonna use to print either alert or warning to the user. I'll remove this function 2 for now. Okay, so to decide this function 1 will print alert or warning. Okay, will print error or warning. Let's take that example. We need some input here, right? So let's assume that input is coming from the calling function, and we'll validate that, and accordingly we'll print here. So if I equal to 1, okay, we'll print this is error, this is a error. Okay, else we'll say this is a warning. So let's keep this scenario very simple. This is a warning. Okay, so we are not doing anything here. We are just taking one input value from the main function, and we are checking that value. If that is 1, we are going to print this is an error, and if it is not equal to 1, we'll say this is a warning. Okay, so in this case, integer I, this is your input parameter. So this parameter, this argument for the function, that also we have to include in the prototype. So this is the integer type. So any type of the variable you can pass here. It is not just integer. You can pass float, character, array, anything, pointer. These all are acceptable here. So for whatever type you are passing, that you have to define in the prototype. Okay, so in this case you are passing integer type. So let's pass. So now whenever you are calling this function, you have to pass that value also. So for example, let's create a variable here, integer x. Okay, and let's assign x equal to 2, and while calling this function we have to pass this parameter. So two things you'd see here. Here in main function we are using variable x. Okay, and that's what we are passing to function 1, whereas in function 1 we are using variable I, and that's what we are using in our function 1 to define the processing. Okay, so once function 1 is called from main function, value of x, that will be mapped to I, and it will validate, it will perform this activity accordingly. Okay, so two variables you see here, one is I and another is X. Okay, so these are called your actual and, so actual and formal variable. Okay, X is your actual parameter, and I I is your formal parameter. Okay, I is your formal parameter because this is not the final parameter. This is being used here just to define the code, just to complete the functionality. But in runtime, your actual parameter will be X. That is what will be coming to the function X. So this is how you can remember what is actual parameter and what is the formal parameter. So let's compile and run it now. No error. Let's run it. So since we are passing 2, so we are assuming we'll get on the screen this is a warning, and you are in function line 1 and line 3. That's what should be coming on the screen. So you see you are in function line, main function line 1, and you, this is a warning, and you are in main function line 3. So this is how you can pass the values between the functions. So this is not just only one variable, you can pass multiple parameters or multiple variables to a function with different type. Only thing is just you have to define that, you have to declare that also in the prototype and in your uh, definition. And whenever you are calling, make sure you are passing all those variables. C will not allow you to skip any variable, and the sequence also you have to follow the same sequence. In the sequence you have declared your function, in the same sequence you have to pass the values also. Okay, so let's see this example for now. So I have, so in this function and here inside I'll just print the value. Okay, whatever user is entering I'll print here, so that part I'll take care here. You entered, let's say, integer x I percentage d, here also percentage d, and here percentage c. So whatever user is passing from there, that I'll print. Let's say here it will be I comma, let's say this one as j. Okay, I, j and c, I comma j comma c. Let's say this, and here I'll assign simply x is equal to 2, y is equal to 4, and let's say c equal to y. I'm not doing anything, I'm just simply assigning these values, and now I'll call this function. So to call this function I'll map these values, these actual values x, y, c, which will be used by our function 1, and it should be printing these values. So I compiled. Okay, you see one error, line number 31 expecting semicolon. Okay, so let's put this one, compile, no error. Let's run it now. So it should print you enter 2, 4 and y. That's what we are assuming it should say, 2, 4 and y. You see, that's what came. Another thing, whatever we write here I, j and c, and what is the variable name here x, y and c, these are totally independent. So for example, if I mention here also x, y and c, okay, still the name are same. This is x, this is y, this is c, but these two are two different variables. These two are totally independent to each other. Whatever value is there in x, y and c in main function, and what is here, whatever get assigned in function 1, those two will be totally independent. So let me show you that also. So inside this, okay, so here we are using same variable name now, and I'll show you how these two are independent. Okay, so in main function I have assigned x equal to 3. Okay, but here I'll change that value to 4. Let's say 12. I'll change value of x to 12. Okay, and let me print the same value in main function also after line 3. Okay, so x, y, z. So here also I'll change the variable name x, y, and c. Sorry, not z, c, x, y, and c. So these are very few very important points you need to understand. This is what we call the scope of variables in C. If you see here, even the name is same, even though the name of variable is same, here x and x, y, and y, c, and c, still the these target to different addresses in memory, and they can store different values. So let's execute it. Okay, so here we are printing inside the function 1, and here we are printing the value of x, y, and c inside the function main. Now if you run it, you will see different value of x, y, and c. So in function 1 you will see 12, 4, and y. You see 12, 4, and y, whereas in main function you see 2, 4, and y, because in main function x was having the value as 2, whereas in function 1 x had the value 12, and that's why it printed two different value. So you can understand here, even the variable name is same, they are stored in different memory. That's what you need to understand here. So they are stored in different memory location, and they can store different values. So if you refer x inside function 1, this will that will refer to this variable x, and if you refer to x variable x inside function main, that will refer to this x. So we learned about how to pass the variables and the scope of these variables. So scope of these variables are restricted to those functions only by default. If you want to pass these values from one function to another function, variable name will not be sufficient. You have to pass the address of those variables, actual memory location where the value is stored, that you have to pass. Because as we know, x, y, c, all these are variables in C, so the value they are storing that may vary, but the memory location where these values are stored, that will be constant throughout the program for those specific variables. So this may seem little complicated, but once we move to pointer, you will understand it better. But for now, you understand values of these variables are values of these variables may change, but the addresses of these variables will be fixed throughout the program. So if you want to pass the value between the functions, you have to use the addresses of these variables rather than just variable name. Okay, so we have learned how we can pass the parameters. Now we need to learn what if we need to return a value from the function. So for this, let's create a simple function which will calculate the square of a given number. Okay, I'll just remove all these things. Okay, so user will uh, enter a number, and we need to calculate the square of that function. So for that we'll create a function square. Okay, so let's say square, and to this we'll pass a input x, and this will return also. Okay, so let me show you one more thing about C. So let's use float for now. Float type as a return and float as a input. Okay, so this is your prototype. This is done. Let's create this also as a float type, and we need result also to store. This also as a float type. Okay, and we'll prompt to user enter a number. Okay, let's use scanf percentage f, this is float. Okay, and ampersand x, so we'll get the value of x from the user. Now we'll calculate result by calling our square function. Okay, since this will return a value, so we can assign that with result equal to, so whatever value this function returns, that will get stored to result. And here you can pass the parameter, actual parameter, that is your x. Now let's define this function. Here you don't need to pass the parameter name, formal parameter name, you just need to pass the data type. So here let's say this is input a. So as I said, this variable name doesn't have any effect with this variable name, so you can use a, b, c, d, x, y, z, anything. And let's define here float b, and let's say b equal to square b equal to a into a. Okay, that's what will be square of a. So let's define that, and to return this value we use a keyword return, and we can say inside the bracket is optional, without bracket also you can return the value, and we'll return this value b. So what will happen here, a square function will be called from main function by passing x is whatever user enter. Inside this function definition, square x will be multiplied by itself, and the result will be stored in variable b, formal variable, and that will be returned to main function. And here once it returns, so this will have, basically this will be result equal to b. This b is calculated value inside the square function. And now let's print here result is, let's say square, let's say square of percentage f is percentage f. Okay, so I'll map here x and result. So okay, so let's run it now. Compile, no error. Okay, now let's run it. Enter a number, I'll say 1.5. Oh sorry, mm, let me run it again. My keyboard didn't work properly that time. So I'll enter 1.5. So you see here square of 1.5 is 2.25. So it is working as we expected. So one thing here, by default any function takes integer as a return type. Okay, so if you miss here return type, okay, like we defined float earlier, right? So if you miss here, compiler will take int as a default return type. So let's see what happens if we miss that. So I'll compile it again, you'll get a warning, ignore that for now. And now let's run it again. I'll enter 1.5. You see square of 1.5 is 2. This happened because even though it calculated 2.25, but it returned that as an integer, and which suppressed that dot 2.25, and it returned result as 2. So you got here, so by default return type will be integer. So whenever you are dealing with float variables or some other variables and you need to return that, make sure you specify the correct return type. Otherwise by default it will take integer, and you may lose some of your actual data. As you see here, 0.25 is suppressed. So that is one more thing. Another thing is, from your called function you can return only one variable. So for example, so let me put float again here. Okay, this is your float, here also float. Okay, and if you map multiple variables here, okay, so from a calling function you cannot return from your called function you cannot return multiple variables to your calling function. And as I said, right, you can use bracket also. Okay, so you cannot return all multiple variables from called function. So if I use b comma 10 comma 20 and compile, it will not throw an error. Okay, but now let's run it, and I'll show you what will happen. I am saying zero point 0.5, but you see the square of zero point 0.5 is 20. This happened because the rightmost value, whatever you are returning, rightmost value only will get mapped. So you'll not get any execution error or execution warning during compilation, but you'll not get expected result because this is logical mistake. So C will not say this as a error, but this is the logical mistake you are doing in your code, and you will get the rightmost value whichever you have passed in return, that will get assigned to your calling function. So if you pass here 120, so whatever be the result B, that will not get returned, and every time 120 only will get returned. So let me show you that again. I entered 5, it should have written 25, but you are getting 120, the rightmost value. So I think you got most of the points here. So let's get into our slide and we'll see what all we covered. Okay, so we learned about actual arguments and formal arguments. You learned about function declaration and prototype. This is important. Here it is, we specify what is return type of the function and what are the type of parameter it accepts. We learned about function definition, the actual body of the function, and return type. By default it takes int, and if it is not returning any value, we need to specify void. If you leave blank your return type, that won't be considered as void. By default that will take as an integer, so be careful here. And function can return only one value at a time, and if you are passing multiple values, the rightmost value will be returned from your call function to the calling function. Another thing we learned about formal arguments and the actual argument. If you change the value of formal argument, that will not have any impact in the calling function. This is what we are saying here. If the value of formal argument is changed in the call function and the corresponding change does not take place in the calling function, by default the scope of variable is local to the function in which it is defined. So we also created one demo function, right, where we change the value of x from 2 to 12 in your called function, but that didn't have any impact in the calling function. This is the syntax how we use. We define return type, function name, and the argument data type on the top for prototype, and we on the below we give the definition. To call the function, we need to call the function, give the function name and pass the arguments. We learned about the function advantage. We avoid rewriting the same code again and again in the program. If we get more changes related to any particular functionality, we can easily modify that in the function. We don't have to change that at the multiple places, and using functions you can implement top-down approach. So I hope you understand the logic and you understood the main key points related to the function. Try it by yourself. Try to create few more functions to implement small requirements. For example, create one function to take the input from the user, create different function to show that to user, create a different function again to perform some validation and throw error or warning. So this is how you can divide a bigger problem to a small problem and try to create functions for those. There's no harm in creating a function even for the small requirement. So if you have any question related to function, feel free to put that in comment box. And if you like this video, please feel free to like it, share it with your friends, and don't forget to subscribe our channel. Thank you. Thanks for watching.